All right, guys, so this is the projectile motion apparatus. So if you guys notice, this device is placed on some table, right, to give us some vertical displacement. We have some distance x, our x displacement. Essentially, we're going to load this metal ball right here onto the spring-loaded gun, and we fire it. It's going to travel some x distance, some x displacement, as well as drop some vertical distance because gravity is acting on the ball. All right, that's pretty much the experiment. Now, when you come to the station, what you're going to see is this pendulum in the way. The first thing you want to do is move that out of the way, right, and lock it on this sort of tract, right? The reason for doing so is that this pendulum, right, is basically part of the other half of the experiment, the ballistic pendulum. And so rather than firing the ball and watching it travel some distance, the ball is going to get caught in the pendulum and it's going to swing upwards. But you don't need to worry about that. That is going to be for lab 13A. So with this experiment, we are not going to be measuring the time it takes for the ball to travel from its initial point to the end point, right? In the PowerPoint, I go over sort of the derivations and the substitutions we have to make that change. And if you go through the further derivations and the actual data, the lab tables, you'll notice that we're only taking two measurements. The first one we're taking is our vertical displacement, right? And the second one is going to be our horizontal, or our x displacement. And using those two along with gravity, we can figure out what the initial velocity of the ball coming off the spring gun is. Now, when you measure the vertical displacement, what you would do is you would more or less measure from the bottom of the ball to the floor, all right? I do not have it with me, but there's a device that I mentioned in PowerPoint called a plumb bob. Essentially what that is it's a huge rubber mass tied to a string, and what that allows you to do is to draw a straight line. So you can take your meter stick to it and measure the vertical displacement with accuracy. So the next thing we're going to be measuring is our x displacement, and that's the distance the ball travels from after it's fired on the spring gun to our carbon paper where it makes our indentation. So for this, we're going to be measuring the center of the ball to the center of our point it makes. Now, unlike the y variable, or y displacement, where we're measuring from the bottom of the ball to the floor, we're actually going to be measuring from the center of the ball. The reason for being is, if you notice, this part right here, the bottom of the ball, is what's going to actually hit the graph paper or the carbon paper first, right? So that being said, it's probably much easier to measure the center of the ball, which aligns with the bottom of the ball, as opposed to just continuing to measure the bottom of the ball to our graph paper.